right, so I'm gonna turn off the transcription. All right. So the goal today is going to be to try to create like a line of thinking for the project. This is not going to cover all the aspects, but it's the way that I would be thinking about it. So you guys are learning how to actually create this idea of let's start out of nothing and get to something. So so let's try to give you guys an insight. So I'm doing this because many groups are doing kind of the same strategy, like of just buying things without thinking thinking truly like what they want to order. And I don't want you guys like running out of budget at the end and have no car to run to race. So all right. So if we think of like a remote control car, so you're gonna have the two wheels, right? You're gonna have a motor to drive the wheels. Like I don't know what kind of like a. So we're gonna have the motors. You're gonna have the wheels. Then you're gonna have a body of some sort. And I don't know what if we're gonna do like a quad tank, or you're gonna have to have like some kind of a steering. Let's leave it there, and then if you remember anything, then we can just add. All right. So if we think of wheels like we can have a diameter, and we have let's see, width. What else can you get out of wheels? We can have grip or traction. Yeah, let's keep going. So like motors. So now we are gonna do DC motors, right? Let's see, we have RPMs. That's the specs. Voltage. Current. Torque. Let's leave it open there. Let's see. So the body, let's see, we have length. Then steering. Height. I don't know if that would be a problem. But steering, we can think of tank, or we can think like a right pin. All right, so these are many aspects of the car, right? So let's start thinking. So it's difficult to set up where we're going to start. And I believe that that's one of the reasons why it gets difficult to pick things in a way that that like it's organized, you know. So let's see. First, I believe you guys have to come up with a strategy. I already talked about this on the in a lecture that I gave you guys like last semester. So strategy is going to be like okay, what's the max speed? What's the of the car? What's the maneuverability? I don't know if that's a word, but there it is. So speed, how easy it is to control. Right, so control. Let's see, clearance from the ground. let's see, width, length, weight. So all this can actually build the strategy that you guys are going to have to win the race, right? So you want to see how fast you want to move. You want to see what's the width of height, length, if it's easier to go through a certain obstacle, or clearance from the ground if it's easier to go through a certain obstacle um, with any of these specs. You have to be also within the specs with with like what was given to you. But in general, the idea is like you have to come up with a strategy, and you can actually tweak strategies, but like technically, it wouldn't be nice if you have to rethink everything, which is possible that's going to happen. But like we're going to try to have like a decisions made and decisions. So like we're going to start from here, and here is where we're going to get. It's where we want to get, and there is a chance that along the way, our decisions are going to actually take us from our path, which is actually very likely that this is going to happen, because like it's impossible, like with little to no knowledge of this subject, that we're going to be able to do something without and make all decisions correct. But the idea is, even though we're going to be steering, like we are not going to get very far from where we started, right? If you guys have to do this, let's see, you're going to decide here and you're going to decide there, and then now this is not the target anymore, because after you rethink this, your target is here. So now you're going to have to steer like this, and actually that's when you have major problems, especially with budget, because then you're going to have to change many of the aspects from the car, you know. But the idea is actually, let's try to finish as close as possible to our first goal, right? So here is like so this is based on the strategy, all right? And what I understand about this, and how it makes it extra difficult, it is that it's kind of difficult to actually think of the numbers based on our understanding in life size of everything. Let's say when you look at your car, let's see the RPMs of the car. You have there, let's see, 1,000, 2,000, 3,000, and so on, up to like so this is red, and then 8,000, right? And in our car, it usually idles around here, right? So that when the car is not running. But like so I guess a lot of people are going to say, 200 RPMs is not a lot, because in my car I go like 1,800 RPMs, 2,000 RPMs all the time, and I'm not that fast. So the problem is, let's do like a quick number here. So let's say I decided to use 100 millimeters diameter of my wheel, right? So this is my wheel. Then what I can get from there, let's see, and I decided to do the 200 RPMs for the motor. All right, so based on this, let's see, let me get my calculator here. We can do like some simple, it's like this, not even going complicated about this stuff, you know. So let's see. Let's see, 3.14. So if I do, so that if I get the length of my wheel, so that's gonna be 5 times the diameter. So, or yeah, so like but this is in millimeters, right? So let's turn into meters. All right, so that's length. So I'm gonna have 200 rotations per minute. So my speed is gonna be 200 rotations, and each rotation is gonna take me this far. All right. So this is in meters per minute. All right, which is 62.8 meters per minute. All right, let's take this to is this right? Let's see, 200 and 0. All right, so 60.8 meters per minute. So this, if I divide by 1.6, I take to 39.25, just so you guys have an idea. Miles per minute, right? Okay, now I'm gonna get, I'm gonna try to make this in hours, right? So I have to multiply the top by 60 and the bottom by 60, right? So times 60. So if you pick this diameter of wheel and you pick this RPMs, that's like how fast you're gonna be going, if my math is not wrong. So like the, and I can be making a mistake, but like I see like it's actually linear thinking of like, okay, so maybe if I pick this wheel, so like why did I pick like 100? Maybe it was because of my strategy, right? So my strategy influenced on this, and I didn't think of the other, of like of the motor, and this, and that's where I landed, you know. So once you start picking things and you stick to it, then now the next decision has to be an educated decision. Otherwise, like you're going to be buying things that you're not going to use, and you're just going to have to keep buying things, you know. And then the chance that you're going to go over budget, and then let's say you're going to do like a tank drive right now. Let's say you're going to do a tank drive, so you need like 4 motors. You buy 4 motors, and then you spend like $100 in motors, and then later on you have to change things, and then now you don't have enough money to buy 4 motors anymore. You can only buy 1. So now you have to go from a tank drive to like a racket pinion steering. You know what I mean? So like that's when I think you go in one direction, and then you have to, so you can actually accomplish something, you have to just like change your plan, like in a very drastic way, you know. And then so like that's where what we're gonna have to think first. So um so let's put this aside, and let's start from a blank sheet. So like okay, so like on the previous one I had strategy. So my strategy was, so I had like a max speed. Next one is control. And then let's say clearance from the ground. Next one here is width. Next length. Next weight. Oops. All right, so this is what I have here on my list. There might be more things, but like I just like trying to think through quick. All right. So what's a good max speed? Let's see. So again, like this is real life impact, on our thought here. If you think, when I go like 20 miles an hour in the car, that's a pretty slow, but it's just because you're trying to move like a mile, But like let's say, what's our longest stretch there for the race? So let's see, our longest stretch is going to be, I don't know. So you'd have to go and try to measure there. Let's see, it's 20 meters or something like that. All right. So if you go there, you get a measuring tape, you put it on the ground, and then you try to run fast, or you have a remote control from your sibling, or any kind of like a thing that you want to do to go fast. In here, let's say you get to 9 miles an hour is actually pretty fast, which I think is pretty fast. Like I don't know, so now you're kind of like setting the max here. I know that everybody's gonna say, "Oh, I have a speed control thing," and then I'm gonna use my speed control to go between 0 and 100 miles an hour and 60 miles an hour. Yeah, it doesn't work quite as like that. The speed control doesn't give you this. Like we think of this being like this because of either our car, or when we Google things, we're gonna get those RC race cars, the professional ones, the cars that cost $5,000 for a car, which I wouldn't go in this direction. It's possible to actually do something like this, yes, but I wouldn't go there. It's complicated to create this. It's not only like a voltage thing that you're gonna apply, right? So like one thing to begin with, if you were thinking to order, let's see, let's go back to this one. Oh, I'm gonna order like a 200 RPM motor, and then I'm gonna create a gearbox. Yeah. Good luck, to make 2,355 go down to 10 miles an hour. It's so the gearbox that they have to be here, it's pretty. All right. So usually these things never work. So the idea is like when we Google those IC car, or let's see, oh, those have those Traxxas motors that has a 12,000 RPM. Yeah, but they have like a metal gearboxes that cost like a ton. Usually when we see parts, we actually don't see the whole. Right now, we are going to have to have actually pictured the whole and try to see how all the parts are interconnected. So all these parts are interconnected, and all the specs of them are interconnected. So we can actually steer, but we are not going to have a major impact on our stuff, right? All right. So first thing is to start with a strategy. And strategy is going to be based on how you want to maneuver around your obstacles at the same time that the strategy actually stay, and you have to stay under budget. That's a good strategy too. All right. So how do you make so like your decisions are steering around? You have to make educated decisions, right? Educated decisions. So like let's say everybody has enough parts for a car, right? So let's say you guys are gonna build the easiest car possible with your kit. So those are those yellow motors with the wheels that you got. What I would do is actually I'll put like I'll 3D print the base. So you can attach this. So like, I don't know, you can use like some tie wraps there. You have holes on the one. All right. You can screw in or glue, or I don't know, your uh, swivel wheel there. All right. Now, this card is not going to require any, it's actually for testing purposes. We are not going to require any controls, just forward, right? All right, so you're going to make this big enough so you have, so you can put the 2 battery packs here. You guys have 3, right? So like you can even do 3 battery packs. All right, your guys are going to have your motor driver. You're going to wire this thing together. So your batteries are going to go in parallel. So you can use the current from all of them. So if you say, oh, I'm a civil engineer, I don't know what you're talking about, like about your E or your ME guy should know this. All right, we're gonna add up so now I have the pins here that I can just like make the car select to actually power the motors. You're gonna power both motors. You grab the car. You go there, you mark down with tape, beginning and end. You put the car here. You wait for it to actually go straight, and you're gonna get time. So now you have time and distance. So now you have speed. What else do you have? You know the diameter of the wheel. So this is known. So you get the RPMs of the motor, right? So you have this. So you have that. You know this. You get that information here. What else do you have? Let's see. Something that's easy. I'm just going online here. I'm gonna type Arduino yellow. So Arduino geared motor yellow torque. I wouldn't trust this information as a so it says that this motor, the ones that you have, it has 800 grams per centimeter at 3 volts. We're gonna be applying more than that. So like okay, but like that's a good start. Let's see. This is actually the first website that I came here. Just so we have an idea for like what the numbers are. All right. All right, so like now we have some information here. Write them down. Okay, get this car, make it on a straight line, make it go uphill, put some extra weight here. So let's see what I can do here. I can actually have a piece of wire coming out, have my multimeter here, and measure current. How much current is this actually drawing? I can try in a straight line, but there's going to be current 1 or total 1. I can actually make my car go up a ramp. So there's going to be current 2, and all these are going to be different, right? But at least I have an idea of like how this is going to work, right? All right, so now we have data, and then now you can start actually changing things. Remember this. So now this is where you are. The yellow car with nothing on. So now we're going to steer a little bit. So you guys have free access to, I hope I didn't lose you guys here. So you guys have free access to the 3D printers there, right? All right. So the one that's the easiest one to change are the wheels. All right. Now, the wheel here, we're going to change. Let's see this. Let's see, what's the diameter of this yellow wheels here? Oops. Just a second. I'm not going to leave you guys there. So these wheels are 2 inch and 3/4. All right. So let's say you want to go with like a 6-inch wheels. No problem. It's going to give you a little trouble here, but like, let's see. So we're going to print 6-inch wheels. All right. All right. Let's say one of your strategies is actually have like a width. So like if we do this design, this basic design, the width of the wheels actually add to the width of the car. So let's say I want to make it narrow. So print 6-inch narrower. All right, wheel. All right, you printed it, you put it here. This setup took a little bit, right? Let's say this took you guys a couple hours to put together. Printing these wheels would take you like an extra 15 minutes. You can just hook up the things there. You'd have to add a little block in between your, so like your car that was like this. Now it's gonna have a larger wheel. So now you're gonna have to have like a little block just so this is leveled. Some sort of like that. All right. So you're gonna have to print like a little block to go there. because the wheels are bigger. So like I can get, and if it's not level, like have it like this, then But I think you're gonna get problems with that. But we're not talking about that right now. So you can do this, and then you can see the problems that are gonna get, and then you can do that one. All right. One more thing. Even this one, like this is something. It's something that I already told you guys, like in the class. Imagine like somebody's gonna make a ramp. Let's see if this at a specific angle. That's like you have from your teacher, like what you can do as of angle for the ramp, like max angle. And let's see, this person used like a 1/8 of an inch plywood board, or like let's say 1/4 of an inch plywood board. So like does it go up the ramp at all, or is it gonna get stuck there? You know what I mean? So like these things you like 2 hours, and you can see if this is gonna work. Right. All right. So you're gonna print the wheel. Now, when you do this, you have a whole new understanding. You can run the same tests, and it's gonna give you some understanding of like how this works. And then you're gonna make another decision that's gonna steer you one way or the other way. You know what I mean? So this is actually the educated decisions that you have. Like, and actually that's a reason why we give you guys a car to begin with. Right? And actually that's why when somebody puts on their Gantt chart, like a build car, this is not like an event. You can say, put together basic prototype. All right, 2 hours. It's gonna be, see, Bill and we'll see. So they're gonna go there and put together the car. Now you have to run first test. And then this test is gonna get data. So we're gonna have the data from here. And like a 3D print new wheels. And then so like it's not one event. Your car is not gonna be built like that. If you have like 5 members in your group, and you're hoping to give one person the steering, one person the motors, one person the gears, one person the remote, this puzzle is never gonna connect. This puzzle is never gonna connect. Because what this guy is doing is actually gonna directly impact this guy, and it's gonna directly impact this guy. So like you can have a couple of people doing this, but then the electricals, maybe they don't know how to 3D print the stuff. So like it's easier to have everybody thinking together and brainstorming and testing, or you have some people coming, because like I know how the schedule can be difficult to actually manage, have everybody together. But like that's the goal, is actually to and then in the beginning, this is going to be difficult to create because we don't know. So like that's why at the end of last semester, I said, I don't mind your Gantt chart right now to be like wrong, but every week you guys should have an idea of what you guys are doing, or you have an idea of what are doing, and then you go and you have a plan, and then you fix your Gantt chart, and then you have a plan for next week, and then you fix next week, and you have a plan for the following week, and then you fix next week. you fix this one, like what you guys have done, and you play the next one. But like at the end, you kind of had a perfect of way, a perfect like Gantt chart, or like if I were to do this again, that's what I would follow. You know. So this is just like a basic understanding of like a how, and this is the car, right? If you think, oh, that's too much, yeah, it's a 3-credit class. So like it's a 3-credit class. So you guys have 2.5 hours during class time, plus let's say 6 hours at home times 4 members. So you guys should be doing 24 hours of work between all the resources. Right? Every week. So that's why, like, I know that's a lot of work, you know. And then we're gonna do this basic steering until we get to our first. So let's see. Let's say about there, or we're gonna get like first final prototype. You're not gonna be making like a huge modifications on this one. But now you were kind of happy with it. Now, so like, let's see, we're there first final prototype. Now, let's see, we're going to do improvement 1. And then let's see, you try to do improvement 1 and you land kind of like right there. It's not going to be perfect. And then you do improvement 2. And then do improvement 3. And again, like, we're going to try to actually picture the goal and try to move in that direction, you know. But we actually have like a final idea for a car way ahead of the race day. All right. So this is the car, not even talking about the obstacles that you guys are building to. But like, this is an overall idea, just to give you a sense of like yeah, it is complex. It's supposed to be complex, you know. Otherwise, it wouldn't take that long. It wouldn't be a class, you know. A class full, you know, all those resources and hours that you're putting into it. All right. I hope like you guys got something out of my rant here about this subject. But yeah, so like this is a general aspect of like what I wanted to point out to you guys. All right, thank you.